Hello everybody, I'm Deby. Today I want to present about system development life cycle. The system development life cycle, SDLC for short, is a multi-step iterative process structured in a methodical way. This process is used to model or provide a framework for technical and non-technical activities to deliver a quality system which meets or exceeds a business expectation or manage decision-making progression. Traditionally, the system development life cycle consists of 5 stages that has now increased to 7 phases. Increasing the number of steps help system analyze to define clearer action to achieve specific goals. There are 7 phases of system development life cycle. First, planning. This is the first phase in the system development process. It identifies whether or not there is the need for a new system to achieve a business strategic objective. Second, system analysis and requirement. The second phase is where business will work on the source of their problem or the need for a change. Third, system design. The third phase describes in detail the necessary specification, features, and operational that will satisfy the functional requirement of the proposed system which will be in place. 4. Development. This phase signifies the start of production. The development stage is also characterized by installation and change. 5. Integration and testing. The 5 phase involve system integration and system testing to determine if the proposed system meets an initial set of business goals. 6. Implementation. This step put the project into production by moving the data and components from the old system and placing them in the new system via a direct cutover. 7. Operation and maintenance. The step is when end user can fine-tune the system. If they wish, the boost performance, add new capability, or meet additional user requirement. A good system is one thing that supports the course of a company. Therefore, system development must be done so that the system develops for the better and follow the changing time. But in the process of developing a system, it is not uncommon for several factors to become obstacles, and some of them are: first, human resources factor. Good human resources is one of the things needed for the system development process to run well. But in reality, not all human resources in a company are human resources who can help the process of developing the system, given the lack of high educational history. Second, technology factor. The system development process must be supported by good technology. If the existing technology is not good, then it will be able to hamper the system development process. Third, infrastructure factor. Adequate infrastructure will certainly help the system development process, but conversely, if the existing infrastructure is inadequate, it will hamper the development of the system itself, because of course the inadequate infrastructure cannot be used optimally, which causes the system development process to be hampered. 4. Cost factor. If the cost of the company is sufficient to support the factor that support the system development process, the system development will run well. But conversely, if the costs of a company are not enough, of course, it will hamper the system development process itself. Technology and system development practices. First, productivity analysis or programming control. Productivity analysis or programming control describe the degree of the ability of individual programmers or development team to build and evolve software system. Level of analysis include the individual, the group, divisional, organizational, and national level. Due to this diversity, there is no clear-cut definition of productivity and its influencing factor. Although research has been conducted for more than a century. Second, structured programming. Structured programming is a programming paradigm aimed at improving the clarity, quality, and development time of a computer program by making extensive use of the structure control flow construct of selection and repetition, block structure, and subroutines. Third, computer-aided software engineering. Computer-aided software engineering, or CASE, is the domain of software tools used to design and implement applications. CASE software is often associated with methods for the development of information systems together with automated tools that can be used in the software development process. 4. Object-oriented technology. Object-oriented technology, or OOT, is a software design model in which objects contain both data and the instructions that work on the data. It is increasingly deployed in distributed computing. 5. Auditor involvement in system development. The auditor's major contribution to the system development life cycle stem from her minimizing the degree of risks to the organization and assuring that all aspects of the project are documented fully in accordance with organizational. Okay, maybe that's all from me. Thank you for your attention.